Hi, my name is Declan Gaynor, and today I'm going to be talking about the physics behind curling. Specifically, why a curling stone will curl in the direction that it is rotating. To understand this, we must talk about the stone and the ice. The stone itself is made of a type of granite called Treffer granite, which is hydrophobic in nature. The stones are hydrophobic, meaning that they will repel water by nature that comes up during the match. The stones are also rather heavy, weighing at about 42 pounds or 19 kilograms. Now, the ice itself is also special. The flat ice before a curling match is sprayed with droplets of water. These droplets of water solidify and freeze. They produce an effect that's called pebbled ice. Pebbled ice essentially reduces the friction between the stone and the ice by reducing the number of contact points between those two objects. Now, how do these two objects interact to form the phenomenon that is a curling stone curling in the direction that it is rotating, which isn't the case with other processes? So, to talk about this, we must understand the direction of motion as well as how friction interacts with this. At the front half of the stone, the direction of motion is to the right, which means that the opposing force of friction is to the left. At the back half, the direction of motion is to the left, so the opposing force of friction is to the right. Importantly, the amount of friction at the front and the back are not equal. That's because the curling stone has a tendency to tip forwards as it slides down the ice, which pushes down harder on the ice than in the back, which generates more friction at the front. This phenomenon explains why when you push a upside down glass that is rotating to the right down a table, it will curl to the left, because the friction at the front is greater than it is at the back. The opposing force of friction is to the left, which is what causes it to curl in that direction. However, curling, since it is on ice, this happens due to another phenomenon. The high pressure between the ice and the front of the curling stone warms the ice more in the front, which creates a very thin liquid film of water. The melted ice acts as a lubricant to reduce the force of friction at the front of the rock. The friction at the front of the stone, which is exerted to the left, is now less than the friction at the back, which is exerted to the right, which is why a curling stone traveling clockwise will curl to the right. Thank you.